Hello everyone and welcome back to my channel. It's been long since I posted a video on this channel, and that is because I was working on my dissertation. But now that I'm done with that part, I would like to continue with this project so that I share a series of data science and data analysis videos, possibly on a weekly basis on this channel, so that we can continue from where we learned. So with that said, let us embark on this data channel or this data science journey. And today we are going to look at something interesting about analysis of population data and poverty data to give us more detailed information about any project, especially with focus on investment projects, because as we know, most investment projects are driven by population. For example, if a government is going to build a road, it has to ensure that that road is serving the maximum number of people. You don't want to build a road in a place where there's no population. Or if a government is trying to invest in infrastructure, maybe a telecommunication infrastructure, it has to focus on areas where it's going to serve the maximum number of people. And even businesses only consider areas where they're likely to obtain maximum profit based on the population metrics and also the income or revenue potential of those areas. So with that in mind, I'm going to analyze population data and also poverty data for around 44 countries, and this will be an interesting project that at the end of the day we are going to formulate business questions or hypotheses and then test them with this data and then make conclusion based on our analysis. So with that said, I'm just creating a video called a folder called data, and in this data I've provided two data sets. So we have got the population data and then we have got the poverty data. For a start, let me just share with you the two data sets. The first data set is the population data, and this is how the data looks like. It's an Excel, it's in CSV form. So this data has got around 8 columns. The first column is the ISO3, which is basically the name of the country or the short code for the country. So GMB will be Gambia, GNQ will be Guinea-Bissau, SSD will be South Sudan, like that. So it contains a list of 44 countries. And then these are the regions in each of these countries. In some countries, they are known as provinces, others are known as districts. And then we have got GID1. So this is an identifier code for each of the sub-regions in those regions. So for example, in some countries, if you have got a province, then you will have something like a district, and then division, and then subdivision, and then location. So this will be location in that country, or the location code. And then the next one will be the population of each location set. So if in this location named GMB11, the population is this. And this is latitudes and longitudes, basically the locational points of those regions. So it's the central coordinates, not the whole shape of that location, but just the central point of that location. But then the geometry defines the whole shape of that location, or the geometric shape of that location. So these ones for now will not be important, but the area will be important at some point, because the area is basically the area in kilometers squared of that region. So that is the population data set. So the other data set that we have is the poverty data set, and this is shown here. So same, it has got the identifier or the location codes of those regions. So AGO, I suspect this is Angola. And then this one is the poverty range. So this data is provided by the World Bank, and it lists the poverty rates in each of those sub-regions. So if you see GSA P2, GSA P2 basically means Global Sub-Atlas Poverty data for that region, and P01 represents the number or the code below $3.2, and then P02 represent below $5.5, and then P00 represent below $1.9. And then poverty rates, these are just the percentages. So what this data is telling us, or based on the documentation of the data, is if you see 70.5, it's basically telling you that in this region AG011, 70% of the population is living below $3.2 a day. So P01 represents 3.02. And 87.6% of the population in this area is living below $3.2 a day. And then 49.37% are living below $1.9 a day. And this is provided for all those regions that we are looking at. So with those two data sets, we are going to do some very interesting analysis. So I've described the data. Now let's get our hands dirty and start working on this data. So the first thing will be to go to our folder, our working folder. And in this working folder, I'm going to create a notebook. And as you know, you can easily create a notebook by just simply going to your file here, click on new, and click notebook. Your Jupyter notebooks might not look at mine like mine, but it's basically the same thing. I'm using Jupyter Labs. You might be using Jupyter notebooks. Different view, but same thing. All these functionalities are plugged in there. So the first thing will be to give it a name. So I'll say population. It's gonna be population and poverty analysis. Okay. And first things first, I'm just going to describe some of the packages or libraries that we're likely to use. So obviously we're going to use OS. This allows us to move through the folders in our computer. And then I'm going to import warnings. As you know, my Jupyter notebook is outdated, so I just want to suppress warnings so that I don't receive error messages that are not necessarily errors, but just warnings, because some of the packages are depreciated. And then most importantly, I'm going to use NumPy, pandas, pandas as PD. I guess you know these things from our previous works. And then at some point, I'm going to use plots. I'm going to import matplotlib.pyplot as PLT. And I might use other functionalities within matplotlib, like matplotlib.ticker import. This I'm going to use it to make sure that my scale is not scientific, but rather normal values. So I don't want to see something like 1 raised to power 3 or 1 raised to power negative 3, but instead have something like 1000 or 0.001. So having done that, those are the libraries that we are going to use in this tutorial to analyze the two data sets. Once we do that, as you realize from our previous projects, we usually begin data science projects with a business question or a research question or a hypothesis. And as I said, population and poverty data sets are very, very important, especially for businesses and governments when they're planning for infrastructure, investments, or business expansion. You want to know how many people are living in an area that you are targeting. What are their sources of income? How much they are spending? Those kind of information gives you a lot of in-depth analysis on how or where it's viable to invest in infrastructure or expand your business or roll out a project. So in the context of this study, I'm going to just formulate two hypotheses, and you can restructure them to business question. It doesn't necessarily mean that these are the hypotheses, the only hypothesis that you can formulate, but I'm doing this purely for demonstration purposes. So I'll change this to Markdown so that we define the hypothesis. I'll say hypothesis. So the first hypothesis will be, again, I'm going to have this as Markdown. The first one will be most of the population lives most of the population lives in rural areas. And then the second hypothesis will be most of the poor population lives in rural areas. So how define rural areas in this context? So rural areas in this context are basically areas where the population density is lower compared to urban areas. So if you have got an area where in a square kilometer area or an area of 1 kilometer by 1 kilometer, only 50 people are living there, then I will say that that's a rural area. I don't want you to think of rural areas somewhere that is maybe doesn't have roads, doesn't have got electricity, but I want us to look it in the context of population density. And then urban areas will be places where there's a large number of people living per square kilometer area. For example, in a city like Nairobi or Lagos, you might find that over 3,000 people or even 4,000 people are living in a 1 square kilometer area. And therefore, we can say that's an urban area. So our hypothesis is that areas where there are very few people in a square kilometer area, there's a small population, or basically most of those areas, most of the people in these countries are living in such areas. And then our second hypothesis is that in those areas, or those areas are similarly characterized by high poverty levels. And that is what we are going to use. We are going to test that for our data set. So it's going to be an interesting analysis. And the first thing will be to import the two data sets. So import, let's begin with the population data set. Import population data set and explore. So I'm going to do that by defining the folder where the dataset is. So let me just say data path. So I'm going to use an important package OS that allows us to navigate through the folders in our computer in a Python environment. So OS dot to navigate, just point it using path and then use join. And then you can specify. If you don't know how this works, you can check my previous tutorials. We have already done this before. So I'm going to specify the folder. So I want us to look at where our data set is. So if you look at my data set, it's in the folder called data, but my Python notebook is in a folder called code. So this is where my Python notebook, which is called population and poverty analysis, is. So if you want to go to where the data set is, then I have to go back to data, go back or go one step behind, and then to a folder called data. So to do that, here I will have quotation marks and then 2 steps or 1 step behind using those 2 dots, and then specify the folder that I'm looking for, which is called data. So this entirely depends on how you have arranged your data set. So please make sure that you know very well how your data set is arranged, if you, or where you have located your positioned your data. If you don't, or you don't understand this, the best thing will be to have this notebook inside where your data set. So that will be inside here, and then you don't need to specify this, you just call the data set. So that's it. The next thing is to define the location of the population. So I'll say pop path. So it's going to be, so we know that it's in this folder now that we have called data path. So I'll say OS again, dot join, and then just copy the folder name and then specify the name of the file. So to do that accurately, just to copy the name. So I'll copy the whole this. Into parentheses, And then the next thing will be to read it as a CSV. So to read it as a CSV, we are going to use the pandas method called read CSV. So I'm going to read it as a data frame pd.read CSV. You can always use the tab button to help you. So CSV. And then what goes in here is basically the path or my file. So this is important. If you saved your notebook inside where your data is, then you don't need to go through this whole process. The only thing you need to do is to copy this here and paste it here, and you'll be good to go. So you don't need to ignore this if your notebook is inside the same folder as the folder where your data set is. But if you have arranged them the way I did so, then you have to follow this step. I think this is now elementary by now. You should be able to do this. And then let me just read the data to see how it looks like. So I'm going to do pop df and just do head and read the first 5 rows. Good. So this is my data is read successfully. We have got the ISO, which is the country code. We have got the region, the name, and then we have got the identification of that region, population, central latitude, central longitude, geometry, and area. Good. So once we have that, the next thing would be I will basically drop the columns that I don't need. One of the columns that I think I will not need for this analysis, though it's very important if you are doing geospatial work, is geometry. So I can easily drop the geometry column. And this one can be done easily by just doing population df and say pop df and then dot drop. Use the drop method and then specify the columns you are dropping. So you can specify the number of columns, whether there are more than one. So I will say geometry because I'm only dropping the geometry column. If I wanted to drop maybe latitude column, I will say I will add here latitude and close that column. I think I can drop the latitude and longitude because we are not going to plot this data set, so the latitude and longitude are not going to be important for our analysis. So you can drop this. And once you do that, you can confirm to see if that has been done successfully by printing the first 5 lines, 5 rows. So you can see we have dropped those and now we are only having 5 columns. Now, one of the most important things when you're dealing with the population data set is to calculate the population density of the people. So in other words, you might find that you are trying to build enough infrastructure in an area. Maybe your analysis tells you that there are 10,000 people in that area. So, and the threshold for building that infrastructure is 8,000 people. So if there are 10,000 people, then definitely you can build that infrastructure in that area. Or if you're a business, you say that I'm going to establish maybe a gas station in this area. And for me to establish this gas station, I have to serve at least 8,000 people in that area. And then when you look at the data set, it tells you that, okay, in this area, there are 20,000 people. So you'll say, cool, let me establish this business here. But then again, what you might not know is these 20,000 people might be living in an area that is as large as maybe 400 kilometers squared. So it means the probability of your gas station serving all these people is very, very low. So what you need to do is to understand the concentration of these people. How well are they distributed in an area? And this is very, very important information for you to establish whether it's worth building that infrastructure or expanding that business to that area. And for you to do that, you need to know the population density. So the population density is basically a metric that allows you to compare how many people are living within a square kilometer area. And for you to do that, you basically calculate it by dividing the number of population by area. So let's do that and then save it as a new column. So what we'll need to do is create a new column called population density, and you remember from your basic pandas that creating a column is you just call the name of the data frame, and then to create the column have got square brackets and write the name of the new column. So I'll say population density. And it's always a good practice in data science to name your columns, give them sensible names. So I'll say, and probably these names should have a unit so that somebody else, when they're looking at the data frame, they can understand what you are doing by even looking at the basic information like the unit. So I'll say pop density SQKM to mean population density square kilometers. And then once I do that, the next step will be, so I'm creating an empty column that is going to be added into this data frame, but I want that column to be filled with the population density. But we know that population density is a division of population by area. So what I'm gonna do is create divide the population density column with the area column to obtain what I want, and that will be here. It's always a good practice to copy instead of typing so as to avoid issues of white spaces or even spelling errors. Divided by population density again, but now this time I'm dividing it with area. So I'm gonna copy that. Good. And then let me just print the first few rows to make sure that at least it has done that calculation right. Good. So you can see the calculation is okay. It has created a new column, and that column, it has filled it with values that are a product of division of population with area. So you can confirm that easily here by seeing what is the answer if you divide 23 with this. So I can easily do that on my cell here, divide by, and see if it's the same answer. Just for confirmation, but it should be the same. Yeah, you can see it's the same value here. So we have calculated the population density. So what does this tell us? So it tells us that in this area, or in this area called GMB 11, 3,773 people, forget about this because we cannot have a decimal point of people. So 3,773 people are living within a square kilometer area. So within an area of 1 kilometer by 1 kilometer, you are seeing around 3,773 people living in that area, which means that is a highly populated area or densely populated area. So probably that's not a rural area. That will be an urban area based on our analysis. So now, this is the easiest way to do it. You can use a loop to do it, especially now if you are doing multiple columns. You want to write multiple columns, but that is not the goal at this moment. So now that we have calculated the population density, can we try to answer our first question that most of the people live in rural areas? To do this, we need to find a way of looking at or relating the population density with the population here, or even with the classification of these areas. So one of the things that I do, or one of the things that will be important in this case, is to find a way to classify these population density areas. So what are the thresholds? Like if somebody is living below, or somebody is living, or you have a population density of 3,700, like in this first case, what should we classify it as? Traditionally, in urban studies, you will have 4 classifications. The first classification will be urban, a second will be suburban, the third will be rural, and then the last will be remote, where you have got maybe one person in an area of 1 kilometer by 1 kilometer. But you see, if you are dealing with 44 countries, then classifying them into 4 categories is not enough. That will likely skew your data, because probably you're going to have got just a few classifications. So the best thing we could do here is to classify them into what we call population geotypes. So population geotypes are very important in that instead of having just a discrete classification population, you can have kind of something that is more elaborate. Instead of having 4, you can extend them to the number that you want. So in this case, I'm going to extend them to 10 classifications. So the first classification will be population of people above 700 people per kilometer squared. So that is interesting. So if I've got any person living above 700 kilometers squared, then I will classify them into geotype 1. So in this case, I'm going to call them deciles. The next one will be people between, or the population density between 600 to 700. So if the population density is between 600 and 700, then I'm going to classify it as decile 2. And then I'll call that like, if I've got people living between, or the population density between 500 and 600, then I'm going to classify it as decile 3. And then I will do that until the last decile, which will be people or the population density below 50, and that will be decile 10. So that is an area where there's very, very few people in a large piece of land or large area. So that is a remote area in that sense, and that area you want to avoid it. If you're a business operator or you are a government, you don't want to build an infrastructure there unless it's a non-profit making business or an infrastructure, something like a road. You will have to serve them no matter how remote they are. So we realize that now to classify that will require at each point we write a code that will check the population density, and once it realizes that this population density is maybe above 700, then it will give us here the classification that will be decile 1, like that until decile 10. So to do that, I think the best thing would be to write a Python function to help us with that. And then once we write the function, we are going to apply it to create an empty column called decile, and then run that function to give us the values for that decile. So let's quickly write that function. So I'll say, let me just call this population decile. And what this function will do, it will be given the population density of an area, and based on that population density, it will classify it as either decile 1, which is over 700,000 people per square kilometer area, decile 2, like that until 10. So the input is going to be like this. It should be population density. So that is what you need to give the function, and in return, the function will give you the decile. So it's a good practice to define what your function is doing in Python. So let me just do that quickly so that you gather those basics. This is a function. So the reason why we're describing this, so that once somebody is using this function, they know what he's doing. This is a function that calculates or classifies the decile of an area given the population density. I think this is too long. Can carry it down here. So what does this function need? So we can create parameters. These are what the function needs. And you can take a guess. This is your parameter, just the way it is. And define whether the data type of the parameter, so it's a float. Population density can be a float. And then just say what it means. So population density of the geotype. And then we have to write what this our function should return. So if it's not returning anything, you don't need to write that. But here it's returning decile. And I will say this decile is string, so it's basically a classifications decile 1, decile 2, like that. So I'll say population decile category the area. Good. So this is just a documentation of this function so that when somebody looks at it, they know what it's doing and what's required. So this is basically, there's a way to do it, but I didn't want to make it complex, but you can use the lambda function to map this, but I'm just going to use the most elementary one, which is amateurish, but it does the work for now, because I don't want us to go into the concept of lambda and mapping out functions or even using a pairwise iteration. So to make it simple, I'm just going to use a series of if, elif, and else statement to do that. So I'll say if this population density that you're given here is greater than or equal to 700, then the decile would be, I'll say decile 1, and it's good for purpose of clarity to kind of have the thresholds inside that so that somebody understands what's happening. So I'll say above 700. So it tells you that the population density is above 700, and I've used this here to make sure that the whole of this part is on the next line so that it's not so long when you're plotting it. So that is the first case. If the population density is greater than or equal to 700, then the decile category will be 1. And then the next will be elif. Can copy this. Of density is greater than or equal to 600, and it's less than 700, then what should happen is decile should be decile 2. And this is basically 600 to 700. This is important because by the time you are in the last one, you might not remember that what was decile 1, what was decile 2. So I'm just having those values there for clarity. And then we do the same for the next one. So you can basically copy this, but change this to 500, 700, this could be 600. Copy this, make it easier, because you already now understand the logic, but this is going to be decile 3, it's going to be 500, it's going to be 600. I'll post the video and do the rest so that it's not long. So bear with me as I copy it so that we don't have got a long video. Let me do that quickly. Just trying to copy them from where I pasted them. Good. 400, 300, 200, 500. And then the last statement, this is the most important, this is the only part that is important, I think. Anything else will just be decile 10. Decile is equal to decile 10. And since it's from 50 to 700, so I can just say anything below 50. And then this function will return decile. So let's run it. It's telling me that there's an error. 700 to 600. Why is that? 700. Can't see where that is. Oh yeah, it should be. Should add this here. Same to this. Okay. Good. So let's test this function if it's working. Let's give it something like 201. So it should give us decile 6. 201 should give us decile 6 for a fact. Population decile. Pop density. Oh, this one should be population density. So let me just replace each of these. Copied it wrongly. These are errors that you don't anticipate when you're recording the video, so please bear with me. And it's part of the learning process. Good. So you can see it's giving us decile 6, which means the function is working correctly. So now I want us to use that function to create, first of all, create a column called decile here, and then populate it with the deciles, or classify each of these population density into deciles. And then we'll use that when we are visualizing our data set to understand, or to answer the first research question, what is the or test this hypothesis that most of the population live in rural areas. Okay, so the next step will be to create, first of all, an empty column, and then fill that column using this function here. So to create the column, I'll just say our data set is called popdf. So create an empty column, called it decile. Good. And this is how you create an empty column in pandas, just in case you forget. And you can check if you've successfully created that column by just running this. You can see there's an empty column there. And now I'm going to write a for loop to look at, take this value here, put it in the function that we have just created, and then have the results of the decile, and then have that result into this column. So that is pretty easy. I'm going to do for I, that is for every column here in range, which is basically the length of this data frame, 3891. So you want it to go through each of those columns. So range, and then to do that, I'll just use the length len function from pandas, gives you the length of the data frame. So the name of the data frame is popdf. And for some reason, I always just love to test my for loop, if it's working, by just running, printing each of the iterations, so that before I put anything complex, I'm sure that it's working. So let me just print the iterations. You can see those are the column indices, and you can see it's going up to 3890 instead of 3891 because the first one starts with a 0. Good. Okay, so the next step is now to populate these rows of decile column. So I will say the pop df decile or the column dot location for each and every iteration. So for each and every one of these, so whatever you want to be filled there is the decile. And how do we calculate decile? We just use this function here that requires you to put in the population density. So let's use that function, and that function requires us to have population density. So how do we get the population density? So we just take this value of the corresponding decile. So I will take the data frame here and then read each value of the population density, which is here. Have it there, close the bracket, dot loc I, close the bracket, and this should do the job. So let me run it. Oh, these are the errors I was trying to avoid. To do that, let me just suppress them. So I'll say warnings dot, because I don't like seeing them. You can leave them, they don't make your code fail, but I just don't feel uncomfortable with them. So I'll do ignore and run it. Okay, let me run it now. Good. And then confirm if your code has run successfully by doing head 5. Good. So you can see it has populated each of this decile with the category. So you can see 3,773, it's above 700. So it has been categorized as decile 1. 3,970 like that. Now, to answer this first question, or to test this hypothesis that most of the population lives in rural areas, so we are looking at to see that most of the population in densely populated or sparsely populated deciles will be higher compared to population in densely populated deciles. And to do that, let's take advantage of the bar plot. So bar plot will give us categories of this population. So it's very straightforward. Let's write or classify this based on the deciles. So I can easily plot deciles or plot the population against deciles, and that should be straightforward. So first of all, let me just plot them. So I'll do fig and then arcs equal to plt dot sub plots, then fig size, let me define this. I'm just defining the size of my bar plot. So it's gonna be 10 by 7. And then I'll do pop df dot plot and then do kind. So I'm interested in bar plot. And do stacked. I'm gonna have it false. I'll tell you what that means, but some of you might know already. In fact, there is not, it's just false. These are Boolean, so should not be in quotation. It's a data structure recognized by Python. X is that. And then colors. Colors will be, or color. I'll just have it as colors, but I'm going to define colors before I run it. So I'll have to run colors before I proceed with it. Let me see some of the color ranges that I can use. Let me just Google color. I'm Googling the colors, so bear with me. Or you can also take this moment to Google some of the colors that I can put in there. Looking at some of the colors. Suggestion. The first suggestion is sky blue. But if we run this code like this, it's going to fail because I've not defined the X and the Y. So I think the best thing would be to, first of all, I've already defined the figure. So let me just define figure, use the matplotlib. So define the figure, which we said we are going with figure size. Fig size is equal to, the first one will be the length, and the second one will be the width. So I'm going for 7. And then the type of the plot is basically plot bar. So I'm going to use that. And my data frame, which is popdf. But I'm only interested in the decile. So this is going to be the x-axis or the independent variable. And then I'm going to plot it against the population so that we know how many people are living in each decile. So I'm going to use population like that. And then good. Then color sky blue. And I think the next step will be to show my plot, plt.show. If this doesn't work, then we go there, we pivot our table. Okay, this one, throwing in an error. Why is this not working? Okay, so there's this square bracket that I forgot there. Good, so it shows you the population deciles. And what is coming out clearly is, look at the distribution. So color, let me try to see something cool. I don't like that single color. It doesn't look nice. Let me look for I think I can use Seaborn to manipulate this graphic. So let me just import Seaborn here. Import Seaborn as SNS. Jesus Christ. Don't have Seaborn installed. You can install Seaborn if you don't have it by using pip install Seaborn. That is if you don't have it, like me, I don't have it, so I'm installing it. Once you install it, you can delete that cell, so you don't need it anymore. Really? Import seaborn. Why is this not working? Import seaborn. Okay, forget about it. Let's just use the color we have. I don't want to go into details of troubleshooting that at the moment. Let's try RGB. Maybe it's gonna work. No. This is what we got. Okay, so you can see that in the decile 1, there are the population density is highest in decile 1, but we know that that is a highly populated area. So if we consider decile 1, then our hypothesis is wrong, that most of the people lives in rural areas. But you can see that majority of the people here live in urban areas. In other words, areas with over 700,000 people. And then you can see areas between 50 and 75 people have got the lowest population. And then the same goes to areas between 75 and 100. So it's very hard to do this, to clearly tell from this bar graph to see the trend. So the best thing would be look at these deciles and see, okay, at 700, this is the total number of people living in decile 1. But decile 2 has got this number of people. Decile 6 also has got a fairly large number of people. Decile 8, which is a sparsely populated area or low density, has got a higher number of people. Decile 10, remote area, have got less number of people. Decile 5, the same. Decile 3, large number of people. So clearly, it's very hard to tell from this, and we cannot, with certainty, say that this number of people are living, or the most people live in rural areas. So just to make a conclusion, we cannot confidently conclude. So this depends with how you interpret your data set. So in the next part of it, we are going to try to answer the second hypothesis, and based on the second hypothesis, we can kind of make inference to the first hypothesis. So we cannot confidently conclude that majority of the population lives in rural areas. Make that a markdown and run it. So now we are done with the population dataset. The next dataset is we have got, remember we had 2 datasets, and this is very, very important because these are the kind of challenges you will be facing. So in the first dataset, we have got the population and the deciles. We have done that. Now, our next step is, for the population dataset, for the poverty dataset, we are not told how many people, we are just given percentages. So in other words, we need to find a way of combining this dataset with the population dataset and then calculate the number of people or living below the poverty level for each of these 3 categories, and possibly rename them into sensible strings that can give us more intuition. So to do that, we need to find a way of merging this file with our population dataset. Luckily, they have got a common column, and you can take a guess. The column is GID. So we are going to import this file into our Python and then merge it with the population dataset that we have already processed. And then once we do that, we use these percentages to calculate the the number of people living below poverty level. So let's do that. So the first step will be to import the dataset. So let me just put in here a little heading. Data set. Then run it. First thing first, define the path. It's very simple. os.path.join, and it's the same location as our population dataset. So data, and then pov data, poverty data, it's os.path.join. And then the name of the dataset, very straightforward. And then we can run it to see if it has successfully .head. Just run the first few lines. Okay, we have not read the dataset, sorry. Pov df is equal to pd.read csv, and then specify the dataset. Good. So we have imported the poverty dataset. Now the next thing is to merge it. You remember from your basic pandas, introduction to pandas, that you can use the merge function to merge two datasets and specify the column that you want to use. So the two data frames, when merged, I'm going to call them df for simplicity, and then use the pandas function merge.merge, and have the first data set that you are going to merge. The first one is pop df. So that is the first data set, and I'm merging it with the one that I've just imported. That is poverty. And then using which column, I'm using this column here, GID, which is the common column. And then I want to merge them or do an inner join. So if you don't know what inner and outer join means, please look at my previous tutorials on introduction to pandas. And then I'm going to print or just do head to show the first few lines to see if it has done so successfully. Good. So you can see we have got poverty rate and the population data set merged together with the deciles. Great. So the next step is I want us to calculate the population that is poor based on these percentages. So in other words, for the case of this first column here, the population that is living below poverty level will be simply be 4.9, which is a percent, divided by 100, multiplied by the total population, and that will give us the population of the people living below poverty level. So let's do that. So if I do that correctly, it's very straightforward. Df dot so let's create a column, a new column called poor population. I think there's a better word, but for now let's just use this. So we are creating a new column called poor population to indicate the number of people living below poverty level. And then that population, to calculate it, is simply we take this percentage, divide by 100, and then multiply by population. So I'm going to say poverty rate, which is this, divide by, is it division? First of all, we divide it by 100. So let me have that under bracket so that I'm sure my Python is not messing up with me. First of all, divide that by 100 and then multiply it by the population, which is population, and then close the two. And of course, you don't want to have population that is fractions, so I'm going to round it to the nearest whole number. And then please confirm that it has done that by printing the first few lines. Good. So you can see it has used 4.9 divided by 100 and then multiplied it by population to give us 1,174. Now, I don't like the way they are using this kind of weird looking numbers to signify different population thresholds. So as I said previously, this one with the no number, GSAP2 poor, this means below $1.9 a day. So that one I got the information from the documentation. So it is below $1.9 a day. In other words, that is the number of people living below $1.9 a day. The second one with 1 is below $3.2 a day, and then with 2 is below $5.58 a day, which makes sense because if you look at the number of people who are living below $1.9 a day is only 0.1%, and then those below 3.2 is below 5.5 is a whooping 36%, which means most people do not live do not use more than $5.5 a day. And then there's 4.9, which represent 3.2. So I'm going to create a new column that renames each of these into more sensible values. So I'm gonna write a loop that checks if it is this one, then it names it to 3.2. If it's 2, it names it to 5.5. And if it doesn't have got any value, it's gonna name it to 1.9. So first of all, let me create that new column with the most sensible classification. So I'm going to call it poverty threshold. And then give it an empty column, run it. And then I'm going to do a loop for I think you are now used to this, for I in range, which is the total length. This should be called here. Range, for I in range, then the length of the data frame, df, close it. As I said, I always begin with just printing just in case. It's you don't need to do this, but for me, I try to first of all ensure that it's doing the right thing, and then I'll say if. So if it is this, then it's gonna be 3.2. If it's PO2, then it's going to be 5.5. If it's just poor, then it's going to be 1.5. So I'll say if df, the column name is poverty range, poverty range dot lock I, that is the value in that cell, is, so if it's this one, then what? Double equal sign. Then the threshold dot lock I is going to be 1.9. Good. Elif copy that. The next one is this. The same as Powery. It's going to be 3.2. Anything else is just 5.5. Good. Then check if it has run successfully. So you can see it has created a more sensible column with those values instead of having this weird looking combination of characters and numbers. So now our aim is to check our hypothesis to test if most of the poor population are living in rural areas. In other words, we were expecting to see that a majority of this poor population are living in areas with the poorly populated deciles. So like maybe decile 10, decile 9, decile 8, 7, and 6. So let's do that. So we can easily use the concept of bar plots to show or to illustrate that. So the first thing that we are going to do is pivot this data set so that each of these thresholds are kind of columns, and you can do that easily in Python using this column here, because we are interested in the number of poor people and then the poverty threshold and then the deciles. So let us do that. So I'm going to pivot my data frame. So I'm going to use the pivot function to pivot it such that each of these are individual bars. So df.pivot, and use pivot table here. And then my values will be, the ones I'm interested in is poor population, and then my x-axis will be the index, which is in this case decile, and then the columns will be the threshold, and then there's the first thing I want us to do is we'll go to the next one, but let us first of all just use the stacked plots. So in other words, it's going to show the aggregate of each of these. So 3.2, 5.5, and 1.9. So it's going to show a total of it. Not very useful, but it's just good to have got an overview before we go to the next step. So first of all, let us just have the aggregate. So I'll do a summation of the population, poor population, and you can do that easily in pandas using the aggregate function. you can give it whatever you want, but here it's sum. I want to sum them up. You can do an average if you want to, but that will be, I think maybe we can do sum and then later on do average, but this is a long line of code. Let me just shift it to the next so that at least it looks nice on our cell. No, this is a bad practice in Python. So let's run that. And if we print our pivot, you can see how it looks like so that you have an idea of what's happening exactly. So you can see it has summed up each of these and then grouped them by the threshold. Alternatively, we can do a mean, which is not making sense, but yeah, that is what we have. So let's stick to that mean. And then let's create a plot. So I'm gonna create the fig, the size of the plot and the axis. Then do plt dot, use the function subplots figure size. As you know, we always begin with the length and then width. And then, so I want to stack the bars to each other, like 1.9 stacked to 3.2 and then stacked to 5.5. So I'll do the new data frame, which is pivot df dot plot, and I'm plotting bar kind, should be kind, and then I'm gonna stack them, yes, true, and then I'm gonna have x is equal to x, and then color is equal to colors. Good. And then I will do plt dot show. So how do I set these colors? Let me that ChatGPT that. You can Google or do a ChatGPT quickly on that. So let me just prompt my ChatGPT. So you can Google. I'm just posting to Google how I set up multicolors. I don't want just a single color. I want several colors, but I've forgotten how to do that. So I'm just Googling it. How to I'm looking for options. Look for options. Yeah, so from Stack Overflow is telling me that if I set something like this, then it should give me the colors. But this one requires me to, first of all, import colors from matplotlib. So I'm just going to add that line here. So this is to add the colors and then run it. then try to run this and see if I'm having nice colors. Let me try and print colors and see what values are there. Yeah, so it's giving me some good colors here. Good. So now I can set this as colors here, have it predefined before everything else, and then show the plot so that it has different colors. Name subplots should be plt.subplot. Yeah, good. So you can see this is how it looks like. Basically, the number of people living above $5.5 a day is very high, and these amounts are very high in sparsely populated areas. Like look at decile 5, decile 8, that contains 75 to 100,000 people. So 75 to 100 people per square kilometer area. It's the highest, followed by population in densely populated area, and then population in decile 7, which is again sparsely populated, followed by decile 9 and decile 6. So there's something interesting. Instead of stacking them up like this, it doesn't make sense, because basically what you're doing here is calculating the mean, but that doesn't make sense among the three thresholds, because someone who is already living below $1.9 a day is also living below $3.2 a day and $5.5 a day. So if you stack this plot like this, you double, you are over aggregating this. So the best thing would be to avoid this stacked and instead just change it to normal bus. So I'm gonna do that and change this to false, and this will give us a very nice comparison of the three thresholds. So you can see clearly that more people are living below $5.5 a day compared to $1.9 a day, and majority of them are living in decile 8, 9, and 7. But this might not be a very, very true reflection. One of the things you always do with this kind of analysis is to do or calculate relative values. In other words, for each decile, you want to know what is the percentage of the people living below poverty level as a percentage of the total population. So in other words, you divide this by the total population, and then you multiply by 100. And why are you doing this? The reason why you're doing this is because in some areas like the cities, you will find that more people are living below poverty line. But equally, if you compare that people who are living below the poverty line in comparison to the total population, it's a very small portion. But in rural areas, you will find that, for example, more people are living or less people are living below the poverty line. But if you compare it to the total population, maybe it's 90% of that population. So it means the poverty rates are very, very high in that area. And that is what I want us to do before we make a solid conclusion about the distribution of poverty. So that will call for calculation of relative value. So I'll create a new column here called DF relative pop. So this is the percentage of people living below poverty line, the number of people living below poverty line as a percentage of the total population. So that will be, you take the number of people here, which is poor, and then divide by the total population, which is this here, and once you do that, you multiply by 100 to express it as a percent, and then run it, and let's see what we have. Good. So this is the relative percentage of the population. And now we can plot this. So I'm going to do the same thing. Use this here. Just copy the whole code. And then instead of, before I pivot this, use the previous code. So I'm just reusing my function here, my previous code. So I'm gonna pivot df again. And then instead of having poor population, I'm now going to have relative population. Then let me just use this rel. That is what I'm gonna use here. So run this and then do some. No, do mean, because it's a percentage, and then run it. Now, this shows us something interesting, because you can see that actually, if you compare the percentages, the densely populated areas, even though they're having less poverty level, if you express them as a percentage of the total population, then a significant number of that population is living below the poverty line. And this is especially well expressed in these values, which is decile 2, decile 3, decile 4, decile 5. And then this goes down in decile, lower deciles and higher deciles. So if you fit in a curve here, then probably it will be kind of normal distribution, because you can see that in densely populated areas, the percentage of population that is poor as a percentage of the total population is low. And then the same is also experienced in sparsely populated areas, but within the intermediate deciles, it's kind of distributed or well distributed. So we can come back to our second hypothesis and say, from here, if you look at these values here, then most of the most poor population are living in sparsely populated areas. However, the percentage of poor population expressed in terms of total population shows a normal with majority with less people living below poverty line in densely and sparsely populated areas. And this, I think, is a subject for further research. But as you know, normal distribution always expresses itself in various, or expresses itself in common data sets. And this is a good example where you can see that even though majority of the people are living in, most of the population are living in, the poor population are living in sparsely populated areas. But if you do, if you calculate the relative percentages, then you see a normal distribution is coming up. In other words, a high percentage or a low percentage of poor people are in urban areas, in very densely populated areas, and then again a low percentage in sparsely populated areas, and then just a small portion or the normal portion within the intermediate deciles. So that marks the end of our analysis, and it has been a long video, but I think it helps you to understand the role of analyzing population data sets to give you informed data or informed information that allows you to make decision in terms of where to do investments or where to establish infrastructure or even help somebody who wants to expand in an area. This data set, you can take it a step further and have it plotted on a map to show you the distribution of this population. With that, I think we can put a stop to our video for today. I'm back and I will be posting a lot of data science and data analysis videos. Please, if you have not subscribed, subscribe, watch the videos, comments on the section, and I will upload the data sets for you to practice with in the GitHub. I will put a link below the video so that you can access the data set and work with it. With that, I want you to share the link, like the video, and if you have got suggestions, you can give the suggestion for further analysis or even for further queries on what best to do with this data set. In the next video, we will look at something different with that. Bye-bye.